So in this session, basically, now we are combining this demonstration of research prototypes and the discussion like brainstorming future research topics area. So, uh, uh, so as the authors and then the participants of the MAR 2021 workshop, we are very glad if you can also come up with some of the topics, and then otherwise also, like I think Professor Anton has drafted some topics that we can bring into discussion. Prof. Anton, can you please take the lead?
Oh,
yeah.
I try, but I think all organizers can take the floor whenever they want. So one of the things is, do we have any demonstrations available or videos that people want to share this moment? No. Well, yes.
I can attempt. Yeah. I can attempt to make an AR instrument live if people are interested in seeing such a thing. But yeah.
Yeah, that would be great, Sam. We can try.
Okay, you are the first one. After that, all people will get enthusiastic and share their results or whatever they have to show. Okay, Sam, go ahead.
Okay, I'm gonna have to do a couple things first. Just turn off my. I'm gonna turn off my video and then switch to a composited video with my Windows screening as well. So just give me 1 second. Okay, now I'm gonna put on these headphones that I think we introduced in our talk, and yeah, they've been used in AR for about 13 years now. Since about 2007 or 8, people have been using bone conduction as like an audio equivalent to headsets, because of the way you put them on. I'm sure you remember seeing in our slides that it sits just here and it doesn't obstruct any hearing. So I'm going to be putting them on, and I'm going to switch my computer audio over so I'll be able to hear people through this. And it tells me that unfortunately it's told me that the battery is low, so that wasn't good planning, but I'm sure it will still work. So I have the headset here. I'm just going to plug it in. And it flickers my video because for the purposes of making demos, I have hacked a Raspberry Pi onto the top of it, which allows me to place a camera on the viewing lens. So when I wear this, you should be able to see through the lens that I'm looking through myself. So kind of provides like a way of documenting the experience and demoing the experience to people. So I haven't provided a demo to so many people, so apologies if I'm a bit slow with doing stuff. Also, sorry if this is too small. You might have to make my screen on Zoom a bit bigger. This is a sort of all the windows that I have open on my computer. Here I'm going to be making a music patch, just really very simple. This is Pure Data, it's an open source audio engine. And over here I have Unity, and here is my Unity editor and inspector. These are the hands that will be being overlaid onto my hands. And for this demo, I guess I haven't prepared anything, so yeah, sorry again. But I'm thinking maybe we can have a button that I can press that will change the frequency of a sound that's playing, and maybe that would be interesting in some sort of artistic context or some sort of museum context. So I'm going to start here with the patch with some sort of button that triggers a random number between 0 and 2000. We can test it here. So that works well. I'm going to put it into a sine wave oscillator and put it into the speaker here. And just in the interest of everyone's ears, I'm just going to scale the audio down so it's not so loud. And here we have our very simple audio patch. I'm going to test if it's working and share the audio with you, so you should be able to hear as well. So here we go. Turn it down slightly more. Maybe people can hear this?
It's
too loud?
good.
Just okay?
Yeah, it's okay. For me.
Great.
It was
Yeah,
good.
That's good.
Okay.
That's good news. Okay. So the next step we can do is make sure that we can change this parameter or press this button in Unity. So I will do a receive button. No, let's say random frequency. So I assign this a variable, and if an item or a value comes through this receive object, it will press this button for us and send the value through to the oscillator. So I save this, and next step, I guess we come over to Unity, and I'm gonna, in Mixed Reality Toolbox, find a button. So something like this will work for us. Move it slightly away. And we want to say that when the touch is completed, we want to do some sort of send a variable to the sound patch. So in here, we can write a quick script called button press. Make it public. And we want to first, I might have to look into my notes to remember how I did this. We want some patch, and we want the button that's being pressed. I might just copy this. and we want the name of the object that we made in pure data. Here we call it random frequency. And we can save this parameter control. And on this button in Unity, using libpd integration, we can create a new libpd instance. So this uses pure data. We can make it spatialized like this. We can say, oh, we want to hear it if we are up to 1 meter away from it, and then after that we will not hear it anymore. And then we want to point it towards the pure data patch that we made, which is in here. In the demo, it's called test. So we drag this here. And then I want to add my parameter control scripts that I just wrote here. On button press, here we go. On touch completed, I want a new action to run, which will be to access the parameter control script and run I can't remember what I called that. I need to save it first. Button press. I'll first point it towards the patch. So down in here we can say we want to point it towards this patch here, and hopefully this will work. Button press. Okay, so now when we press this button, it's using Microsoft Mixed Reality Toolkit UI. Wow, this is very big. Didn't realize. Sorry about that. When we press this button using Microsoft Mixed Reality Toolkit, it will send a message to this script here and send a bang, which is like a button press, to this patch, and that should change the frequency of the oscillator. Hopefully this will work. So I will transition now to putting the headset on and switch your view over so you can see through my headset. Hopefully this will work. So now you should be seeing through the headset. There's everyone in Zoom. And when I press play on the Unity scene, what should happen is my hand should be synced and the button should appear in front of me, and I should be able to press it and change the sound of the oscillator. So let's see if that works. Okay, the first issue is that the button is black, and when stuff is black, it means that the photons aren't coming out of the screen. So I will first have to change the material of that to let's see if this works. Should be blue now. I think you should be able to see this now. This button is in 3D in my environment. My hands are being made here, and I guess we should already be being able to hear it, but can someone give me a thumbs up? Is it working? It is working. Wow. Okay.
It's working.
That's great. So yeah, I can move around my environment. I can press this from multiple different angles. This, of course, is which I wasn't expecting to be able to do.
Very good.
Thank you very
Yes.
much.
That was great.
Very interesting.
A live demo that is successful. That's
Yeah.
very difficult,
It's my first one.
but you succeeded, so that's great. Maybe there are, well, comments or ideas, suggestions, whatever for Sam. I don't see. Oh yeah, okay. Sam, I have a question. If you're still there.
Hi, yeah, I am. Sorry, my
Okay.
camera stopped working because of OBS. I can
So,
come back.
Well, it's not really a question about your demonstration, but it's more about application of augmented reality in art, in using augmented reality for artistic expression, things like that. I just wonder, I have this book, I can show it to you. Can you see it? No.
No, we cannot see it.
You cannot see it because it's blue and the background is blue. Well, it's a book that's called Augmented Reality Art. Are you familiar with this book?
Is it by Jerry Menko, 2018 or 2014?
Yeah, 2014 was the first edition, and the second edition was 2018. But the point is that if I read these books about augmented reality and their applications in art, that almost all augmented reality that is used is handheld augmented reality, so smartphone applications, and almost everything is vision oriented. So that may be the case that this is more about research or applications of 2014. But do you think that things have changed? Are there many people nowadays working on augmented reality art and augmented reality art applications? Is there a community?
Do you mind if I leave Zoom and come back again so that my video is working? I just need to quit Zoom very quickly. Is this okay?
Okay.
1 second.
Are there other people in the audience among the participants who are working on artistic applications of augmented reality?
Sam is connected again.
Great.
Okay,
can you hear me?
Yes,
Can we go back to Sam?
Yes, Sam, yes.
Amazing. Sorry about that. Because the multiple webcams, Windows gets very confused. Yeah, that is a fascinating book, especially the second edition that I've read some of the chapters on, and a lot of the values that they portray in the way that they write about how augmented reality has the possibility to make the unseen visible for certain people, or as a method of political expression as well as just artistic expression. Of course, there is a lot of overlap between art and politics. To answer your question about whether or not sound is becoming more applicable in the area, I think yes, definitely. Not only in artistic areas, but also in consumer technology, we see a big shift towards spatial audio as something that companies are now interested in. People are realizing we've had augmented reality all along, since we've had noise cancelling headphones or something similar, applications like that, or similar technologies like that. And the application of those technologies is what's happening in the arts. And there are examples, yes, of sound in augmented reality art. To give an example, I can think of this one really interesting example where, if you're aware of the arcade game Pac-Man, where the Pac-Man goes across the map and eats the small little bits of food. Someone created a real-life version of Pac-Man where you are Pac-Man and you walk in the street and you're being geolocated, and you wear headphones that let you know where the ghosts are behind you trying to come and get you. And through this way you can navigate through a city and maybe find some interesting parts of the city that you haven't seen before. Maybe more of a game rather than a piece of art, but yeah, I would say there's definitely more and more examples of interactive AR systems for artistic or game reasons that are using sound.
Yeah, and of course, if you look at location-based games and urban games, etc., then sound is, let's say, more easy to implement and to use than, wearing a headset, head-mounted device and things like that, even if that's possible in a wireless way nowadays. But yeah. And another thing is, Leandro, you are still there, Leandro?
Yes, yes, I am.
Okay. I can imagine that not only for disabled persons, but for everyone who is visiting a museum, augmented reality is a nice application and a nice addition to exhibitions and things like that. So are you planning to do some work in that direction?
Yes, so thank you for your question. I really like it, the demo. So yes, it's very interesting. But I was just thinking the whole presentation how I could adapt something like that for the participants we have. But the main problem is how can we not be interfering in their natural willing of using technology, because usually we are having technology as something for to enhance their experience and to make it a tool for when they need, not something to make them use into this context of a hardware, and then to have to the preparation, and then to have this not knowing what is reality or not. And this can be a challenge. I was very curious now what would be their reaction, but considering the augmented reality holding a smartphone, I could see that some of them were not really understanding what was in front of them, and they need clearly some hours using to for us to really know if it would work or not, and clearly the content, because his content is more related to music, and in my case, in the museum they go, it would be more animals, artworks, and then how we could transform that, or how the interaction would be. And yeah, but this is very interesting. I think there are a lot of things we can discuss, and yeah.
Okay, you got some inspiration. So from sound, we can go to smell and taste. Kasun, you have some demonstrations about it?
Yeah, Prof, and then we can show some demos. Maybe I will first show. Can you guys see this device?
Yes.
Yeah. So this is very similar to what Nimesha has proposed in 2011 for digital taste. So we made a similar device in our Malaysia lab, Imaginary Institute in Malaysia, around 2015. So what happens is this device
So
can
maybe disable.
Yeah.
Maybe disable the background.
One second, please.
I don't know what's happening. Just continue, I think.
Yeah. So I have disabled the background, by the way. So this is a plug and play device where you have a small circuit which is driven by Arduino board, and then you can connect this device to the computer using a using USB port. So this is a USB powered circuit which runs on 5 volt, 5 volt, and it consumes some small amount of milliampere. So you can see now when I connect this one into the computer, LED popped up. So what you need to do is we can use these two tiny electrodes. So those are made from silver. Why we are using silver? Because silver gives you very less kind of metallic taste. But if you use some other metals like copper, for example, it gives you a higher metallic taste. So what you need to do now is to place your tongue in between these two electrodes. Like this, and you will be able to feel sour taste sensation. So using this device, we can generate sour taste sensations as well as some little bit salty sensations. So we have carried out some user studies related to that, and which gives very good results related to salty and sour taste sensations. And then also we have developed another quite big device. So the again, the main motivation of this one is to create a device that can produce taste sensation on the tongue without using any chemicals. So we hope that since we can digitize the sense of vision and audio both, so we can have some kind of digital representations, right? And we can recreate that one using radio frequency views, so like for example visual frequency spectrum and then audio signals. So similarly we can represent some kind of taste and smell sensation. So that is the motivation behind these works. But using that electric taste device, we were only managed to reproduce taste sensations which are salty and sour. So we have developed another device. We call this one as thermal taste interface. So that is quite bulky, and I can show you only half of the system here. So another half is on my table, below my table. So what we have here is there is a single copper plate. So we are using a copper plate for this one. And then underneath the copper plate, we have like special thermode. So what happens is when the thermode gets the electric power, one side becomes heated and another side becomes cool. So, and then we have like cooler, liquid cooler, which is connected to a fan. So what we can do is we can efficiently control the heating and cooling. So the idea behind this one is when you change the temperature of the tongue at a rapid intervals, there is a taste channel called TRPM5. So about 25% of people, this TRPM5 can generate sweet sensation on the tongue, because it is this TRPM5 channel is highly sensitive to sweet taste sensation. So what it does in normal person is to increase the sensation of increase the sweet sensation. For example, like when you put like cake in the inside the refrigerator, and if you eat, then you will feel less sweet sensation, right? But if you eat that piece of cake on the room temperature, you will feel it more sweeter. So that is kind of effect that can be created by this TRPM5 taste channel. So however, we have found a group of 25% of kind of people where their TRPM5 channel is more sensitive. So even if we do not put any sweet sensations, they can still feel sweet sensations if we change their to change the temperature of their tongue rapidly within 20 seconds. If we go change the temperature from about 15 Celsius to 35 Celsius, we can feel some sweet taste sensations. So we call this one as a thermal taste device, which was published in IEEE VR some time ago. And then the other device I would like to show you is this Senti. So it's a small gadget where you can produce smell sensations. So this is the first gadget which was developed to plug into the mobile phones. So you can connect to your mobile phone like this, and then you can use an app and create some smell sensations. So there is a smell diffuser. So we can take out this. So this part you can we call it a Senti cartridge. So you can inject some like smell, I mean liquids which can create smell sensations inside this. And then there is a smaller circuit which is powered by the audio jack of your phone. So how it can create a vapor of smell, because there is a piezoelectric transducer which operates on higher frequency and make the vapor. So that is the Senti. So this device we are using actual like liquid based, like water soluble smells. So, and as the next step, we wanted to create some kind of device that can purely create smell sensations by electric means. So in order to do that, we try to put two electrodes inside the nasal cavity of a human, and then we have carried out some equipments, some experiments. So I do not have that particular equipment with me right now, complete equipment, but I can show you a video of that one.
Okay.
So hope you can see this.
Yep.
And I will play the video, so it will take for about 4 minutes, but I will try to cut it short and show you only the important parts. You can see you can hear the sound, right?
Yes.
Digital smell is considered as a useful step in expanding technology related to multisensory communication. Previous methods to activate the sensation of smell have several limitations. For example, it has lower controllability, expensive, need to be refilled, and complex. So, in this project, we developed a new interface where we can induce the electrical pulses on smell receptor and generate the smell sensation. We believe by using a weak electrical signal can trigger the smell receptor and generate the smell perception.
The sensitivity and effectiveness of electrical stimulation towards human smell receptors will be tested using a current control device. The intensity depending on each person's capacitance, because different people have a different capacitance. The stimulation process including putting a pair of electrodes inside
Sorry, can you hear us?
Use nasal spray. The function of the nasal spray is actually to minimize sneezing in case the participant is allergic to some things, and the nasal spray is going to help us minimize sneezing. So we just apply a little of the nasal spray, then before we proceed to inserting the electrode and the camera. So we're just gonna go a little deep. As we go deep, we monitor it with our monitor to see when we get to the actual area we are targeting to get to. And the actual area we want to get to is the superior or the middle concha, where we know we have the olfactory epithelium, which is also responsible for smell. Okay. When we do that, we keep on rotating the camera until we get to the actual target.
We hope in future we can develop a combined interface where we can regenerate the smell sensation using this device. This device will be useful for several industries like gaming, virtual reality, entertainment, and also online marketing.
Yeah, sorry about the hearing difficulties like sound related matters you had. But I hope you all have get the idea behind of this interface. So yeah, we have created very small micro ampere level stimulation pulses, and then we have done a user study with 31 participants, and then 8 participants have reported some kind of smell sensations they perceived. So but the sensations are different, and currently we are working on one publication. So hopefully we can make those results public in a couple of months' time. And then the last device that I wanted to show you is we called this one as Ring You. So that is a touch device. So where you can we call this one as mini hug ring. So if you are a couple and you want to share like some kind of touch sensations with your partner, what you can do is you can wear this on fingers, and then when you touch this one device, and the other person feel it as a vibration. So inside we have a touch sensor, and then we have a small battery and vibration circuit. So those days we didn't had those days we didn't had circular kind of boards to create these electronics. So now we can have these flexible circuits, printing boards. So hopefully in future we can further make this device smaller. So this device needs to connect to the mobile phone using Bluetooth connection, and then from there it will connect to another mobile phone, and then connect to the other device. So those are the devices actually I have. So hope you have enjoyed. And if you have any questions, you can ask.
Comments, questions.
Yes, Thomas, go ahead.
Okay, let's see. Can you hear me?
Yes, Thomas. Yeah.
Yeah, I cannot hear you. Let's see.
Okay.
So
okay.
yeah, these are, I really enjoyed this demo session as well. So thanks organizers for including it, and thanks to demo guys for doing all this amazing stuff. Sam with live programming, and you Kasun with a lot of very interesting wearable stuff. So my comment has to do with the since I've been interested in wearable technologies for a very long time, for many years. From a personal perspective, I am very intrigued and inspired by seeing all these wearable devices that you are experimenting with, which points towards the possibility of a multi. There is a very old idea of using augmented reality for mediating the world, basically to have some kind of a mediating filter between you and the world. And by seeing all these examples of wearable devices, I have the feeling that we are getting closer and closer to the possibility of creating such, a mediating experience for wherever you are. And as you move about, we could basically manipulate the sensations we have of our world as we move around. And I think that's really, I really like all these prototypes that we have seen today. They have been very inspiring and point towards such a future. It's not that I dislike the real world, but it's a very powerful, as a user interface designer, and I'm sure many of us who are attending today are, we need more power to talk to the people in the right way. And through these wearable devices here, electrodes in the nose and what have you, there are more powerful channels, a higher bandwidth, if you like, coming. So it's very inspiring. I just wanted to say that it's inspiring to see all these interesting devices.
Yeah, thank you, Thomas. And in the meantime, actually, it was a little bit scary for our participants to try out that, especially that electric smell device, because we had to use that endoscopic camera and then put it into the nose. So we have selected at the later stages, we bought the world's smallest camera, which was made in the diameter was 1.8 millimeter, and which was made in Israel. So we brought it all the way down to Malaysia, and then we did the testing. And then, so by that time it was quite okay for the participants, but previously we have used that 3.2 millimeter camera, so those were quite difficult for the participants. And I think in future, we can use these kind of devices for the good, maybe. For example, like people with diabetes or people who wanted to eat less salt in their meal. So we can create some interfaces. Actually, I think Nimesha has came up with certain interfaces which works like a spoon. And then also there are a couple of Japanese research groups are working on these electric test interfaces these days. So they are also altering the sensations of drinking while drinking and eating using spoons, and then also some kind of glasses, and then provide very small electric current and try to alter the sensations. And Nimesha has made lots of work, but particularly what was our difference in the sense of this research was to purely concentrated on electrical means, and then other energies where we can create sensations without using chemicals. So our motivation was to how to deliver these kind of sensations using zero chemical molecules. So that was our motivation behind. Okay, so I think we can go for the next topic if there are not more any questions.
Well, maybe one question for you, Kasun.
Yeah, Prof.
at this moment, you see, well, a lot of interest in augmented reality. You have all the big companies like Google, Microsoft, Facebook. They are working on, well, augmented reality applications, usually vision oriented, but they are really looking at the consumer market. So in the case of smell and taste, this is not happening at this moment, I think. Maybe you have other information, but what would be a killer application for taste and for smell? Have you thought about it?
Yeah, I think Prof. Anton, like, is still the interfaces that we are proposing is maybe like 10 to 20 years away from the consumer market. But one good example is that this Senti is a Japanese company. So at the first stages, my professor worked closely with this Japanese company to make this into a product. So now they have they sold different types of versions of this Senti, and this is the first version which were also sold in Amazon. And now they have created a device called Senti Machine, so which is powered by some AIs also. Artificial intelligence algorithms, so that can also track your preference and then react and create more than one type of smell sensations. So now it has a few more cartridges, so developed into a new version. I think chemical-based taste and smell interfaces, yes, people are. You can buy. Another good example is that olfactometers and gustatometers that we can buy for smell and taste experiments. So olfactometers and gustatometers we are using to deliver different taste or smells based on a protocol. So in our lab, we have created one olfactometer. So generally, olfactometers are quite costly. So it costs more than $30,000 US dollars on the market. But we created one low-cost olfactometer. If you search on the Google Scholar, you can find that paper, which cost around like 4,000 to 5,000 US dollars. So, and we have used it for lots of experiments in the lab. And so like that, there are certain devices which are in the market, but some devices are specifically made for experiments, like psychology, smell test experiments like that. And there is a tiny market for these Senti-like stuffs, and I have seen a couple of more commercially available devices for smell.
So all these applications are, let's say, in the area of entertaining food experiences. So entertainment, games. Well,
Yeah.
maybe for
I
food
think,
you can think of other examples too. For
in terms
food,
of in terms of entertainment, the first that type of project was called as Sensorama, so which was built in 1960s. So that was to, the idea of that project was to provide multiple multisensory experience while you are watching a movie. But I think that particular product was not ready by that time, so it was a failure commercially. And then, but now I think with this 3D, 4D, 5D cinemas, people are interested on creating like smell sensations, wind effects, rain effects, and haptic feedback, etc. So I think we are getting there, and maybe in few years' time we can see more devices related to those topics. But still, we are limited to this using chemicals for smell and taste.
In fact, the talk by Nicole Tobiskova, it was, I think. So there you had the use of smell. Yeah, the use of smell in a professional environment. So are there more examples where you're using smell in a professional situation? I'm not sure whether Nicole is here, but otherwise other people can maybe.
Yeah, I'm
mention.
here.
Yeah, she's there
Okay.
with Thomas.
Yeah, I'm here, but that was the only application we thought about. I think that using smell for some dangerous gases or danger.
Yeah, we are
Signified danger.
right, danger, but also any kind of subtle piece of information. We haven't talked so much about time here or decay, but we have. I don't know, Kasun, you have more experience with smell, but it's a bit of a slow modality, isn't it? So it comes and goes
Yes, Thomas.
slowly, and the human sensors are also a bit slow.
Yes.
So you have to use it with care in interaction design.
Yeah, especially Thomas. So that like one of the problem that we found was like a person will not feel the same smell after some seconds, right? So his mind get adapted, and then we cannot feel it anymore. So even when we are conducting multiple trials, we in between the trials sometimes we ask people to smell water, cup of water. So if you put it in front of the nose and then inhale, then it helps to reset your nose up to some extent, not 100%. And then the other one is to have some longer intervals between the trials. So we have conducted it like that. Otherwise, the other thing that you can do is to switch between different smells.
I think this idea of resetting sounds very interesting. Unfortunately, the workshop is only one day. I want to talk to you more days, but it doesn't work. But one of the very interesting topics, I think, is the fact that the human sensory system is different for the different modalities, and we need to think about that when we design.
Exactly. And taste also.
Yeah, so it's not so
similar.
easy. That's one of the challenges we have when we, if you want to have, Lars-Erik Holmqvist here talked about the transformation function from one modality to the other. Wasn't that simple, but sometimes it's simply not possible because vision, for instance, is very quick, and you will not be able to change as quickly if you transform that into a smell change. Yeah. So, and that has to do with the human body and our sensory system. It's not that we cannot create the actuators, it's simply our own sensors that are in the way they are. So that's a very interesting aspect of the fact that we are designing for the human body, and the human body has its limitations.
Yeah, I think, Thomas, the number one reason for that, I mean, this is my belief, both smell and taste are based on the chemical molecules. So that molecule needs to go into the taste or smell receptor or bind with that particular receptor, and then only it will create some kind of depolarization and then create the send the signal through the nerves, right? So that to trigger that action potential. So that is, I think, little bit tricky and a little bit slower. That process is slower than the hearing and vision. So I think we need to consider that one, and especially when we are conducting taste-related experiments, we ask people to not to eat anything 1 hour before the experiment, and then we always most of the time we have omitted people who are smoking quite a lot, and then people who are aged more than 60 years old or 55 years old, we have omitted, because with the age also that sensitivity is decreasing. So there are lots of things like that.
Okay, should we go to the next topic, or the next
Yes.
topic in our schedule? It's about future workshops, publications, things like that. So Kasun, you have already some ideas on that?
Sorry, Prof. Fenton, could you please come again? I didn't hear you.
Oh, okay, sorry. I was thinking that maybe now we should go to the following point on our agenda. That is, what will we do in the future, and what will we do with the results of this workshop?
I think we can also ask suggestions from our participants. So far, what I was thinking is that maybe we can, we all can get together and then make a special issue. I mean, of a journal or something like that. So that can be a good idea. So we can try to improve on our position papers, and then maybe we can create a special issue in one of the journals. And I think Professor Anton is leading one journal. Maybe we can consider that one as well. And another one is like at UCSC we have this free and open access journal. So which means like all the publication fee will be waived for the authors, and then for the publication fee is taken care by the university, because it is a university is funding for that one. And then so it is a peer reviewed journal, so we can create a and it is open access, so we can make a special issue there. And another one is one of my ideas, like since we had lots of great ideas and topics we have discussed today, so maybe we can come up with some future collaborations. So we know that each and every person's, like each and every team, what they are doing, and what are their specialties. For example, if we apply for some kind of EU grant proposal or something in future, we can build some good collaborations, like good consortiums to apply grants. So I think that is a very good plus point. So those are the two things that I mainly like to share, but I think all the participants should have some great ideas, so please let us know.
So maybe I can share a screen. That's allowed, yeah. Let me see this one, I think. So these things came up, so we can look at position papers, and maybe people are interested in, well, improving them or just keeping them like this, and they can become part of a special issue. And maybe then it's also necessary to have an open call for papers, and there will be a new review process that will be asked for by the journal, of course. There are possibilities, so we can look at well, the Sri Lanka journal that was mentioned by Kasun, and it's also possible to look at Frontiers journal. They have research topics, and they already have, I checked it, they already have various special issues or research topics. They are called on augmented reality or virtual reality or mixed reality. The problem here is it's very expensive. You really have to pay, well, 1,600 euros in order to get your paper published. For developing countries, it's possible to have the fee waived, so then you don't have to pay. And this is, as Kasum mentioned, completely free. So the university is in fact funding the journal and the publication. So we can consider a special issue in whatever form. We can also look at a next workshop, of course. I would really like to have a next workshop, maybe at the next Interact conference, but that's 2 years from now, and that's a rather long time, I think. So there are certainly possibilities, there are certainly conferences where you can have, well, multisensory augmented reality workshop associated with it. And okay, Kasung also mentioned there are possibilities for collaboration, but maybe they can be discussed well in other meetings, more private meetings. But comments of the participants, do they have any preference or suggestions, things we should know and maybe should take care of when organizing something in the future? I can imagine that especially the people in Italy, in Bari, they are looking forward to their Italian dinner later this evening. That's something we are missing.
I actually would like to comment something.
Good.
I don't see if you can see me. Yeah.
Yes, Vivian, we can see.
Yeah. So I'm still a master student. So I'm doing my thesis right now, and it's based on augmented reality and olfactory display. So for me, particularly, it was really interesting to have all these inputs and understand better how it works. So of course, I'm not expert as all of you. So it was interesting to follow the research and see what is there and what is coming in next in the future. So just saying, particularly for me, it was a nice experience.
That's good to hear. Thank you very much. Okay, Kasum or other organizers. Tilina is here. Manjusri is here. Nimesha is still here, I think. Yeah. Yes. Okay.
Nimesha came back.
Is there something else we need to discuss? Something that you want to bring up, or? It looks like everybody is tired and
sleepy.
Sleepy, okay.
Yeah, sorry, I missed some parts of the workshop. I had to drop my son at the school. I think it's very interesting to hear all the directions, dimensions different people are working on. I think we covered like from the musics to different games, and then the fashion, and as well as the other aspects of the multisensory stimulation. I think it will be great to hear the updates, and probably Kasun and other workshop organizers, maybe we can create like I don't know, a group somewhere where we can exchange and keep in touch in the future, and probably, I don't know, maybe an email group or a social media group or something like that. Maybe that's another way we can keep the contacts, and then if we need help from each other, probably we can chat and ask help and collaborate on different projects.
Yeah, thank you. Very good suggestion, Nimesh. I think we will look into that, and maybe we will create a email group.
Yeah, sorry. I think people are also using Slack or other kind of media channels
Collaboration,
or Discord.
collaboration.
Yeah,
Sure.
whichever, or at
Okay, and
least an email group.
Yeah, right now we have emails for all the participants, everyone who joined here. So we will start
I'm
from
just send Discord link. I mean, if interested, you can join there as well.
Okay.
Yeah, it's just a Discord server if you're interested in AR or VR artworks for low-cost solutions, that kind of stuff. If you're interested, I just put the link there if you want to join.
Thank you, Sam.
Thank you. Thank you. Okay, and of course the web pages will be updated with some information about this workshop, I think. So there will be pictures, there will be, well, access to the video if that's possible.
Yeah.
And maybe some future plans can also be on the web page, I think.
It will. It will. We will add those.
Okay. Maybe we should stop and say goodbye to everyone. And if so, well, I think at least I'm very satisfied with this workshop. Well, I started with a schedule, and after some time it turned out that we could departure from that schedule because everything went fine, went smoothly. We had a lot of questions, and questions turned to discussions and sometimes brainstorm sessions, you can say. So it was not necessary to keep strict to the schedule. So I'm happy, and as I already said, I certainly would like to see next workshop next year or in 2 years. And Kasun and I, hopefully also Nimesha, Tilina, and Mariusri will be available to organize that in the future. So for me, this ends the workshop. Thank you very much. And if Kasun wants to say something, please go ahead, and I will be quiet from now on.
Okay, thank you very much, Prof. Fenton, and then thank you very much all the organizers. So on behalf of UCSC, also Tilina and Manju, I should thank, and then we thank all the participants. And Nimesh, we need to especially thank. He had to wake up midnight and then do his. I mean, just after the midnight, he had to be ready for his keynote, and he was here for the whole day. And thank you very much, everyone. And we are really proud of seeing what you have done in this multisensory augmented reality, and we really hope that we can go into the future as a group of researchers, so we can do some great things in the future. So hopefully we will see you again in another multisensory augmented reality workshop. Thank you very much, everyone, and have a good evening.
Show people that are here in Italy in present.
Yeah.
So
Yeah. Big thank to you guys who made it to the Italy. So hopefully next time we can join with you all physically.
Yes. Thank you. Bye bye.
Yeah. Thank you. Bye.
Bye bye.